start looking at what it means to multiply stuff with like bases. And when we said we're multiplying your exponents, what are you really doing with your exponents when you multiply like bases? Add them together. And then division meant to subtract. Now guys, we're going to start looking at the case. Sometimes when I add and subtract, we end up with some kind of a negative number, or you could end up with a 0. That wasn't the case in the last section. So what I'd kind of like to look at today is this. What are the rules for, whoops, I didn't want that. What are the rules for negative and 0 exponents right up top here? So as we look at this stuff right here, our goal is to be able to work with what we consider a negative. Okay, why is this not working? Because that's not the right one. Our goal here today, work with 0 and negative exponents, all right, and what they mean, okay? All right, a couple big rules right up here. You might want to put a star by or an exclamation point by, but these two rules right here. How about a first volunteer to read my first rule? Who wants this one right here? Mason, you want it? Since you're closest?
For any non-zero number, a0 equals 1.
So it says for any number that's not a 0, it says a to the 0 power is always equal to what value? 1. Okay, I want to show you why this is true here. Okay, but these two rules are true. Quickly. Here's an example. You don't need to write this down. Guys, what's 6 divided by 6? What's 5 divided by 5? What's 12 divided by 12?
1.
What's x divided by x?
X.
What's been kind of the pattern here?
Well, 1.
When the numerator and the denominator are the same, they divide out to be what value? 1. Okay? So here's the situation. By our rules right here, guys, what I've just told you is one thing divided by the same thing is always going to equal what value? 1. Well, don't I have a base with an exponent of 7 and the same base with the same exponent at the bottom? So don't I have one thing divided by the same thing here again? It's still going to equal what value, though? It's going to equal 1, right? But by our rules from the last section, what would you do with the 7 and the 7 to rewrite this as 1 base, 1 exponent? This would be x to what power? What's 7 minus 7 going to be here, guys? X to the 0. So we say anything to the 0 power right here is always going to equal what value? Anything to the 0 power is going to equal what value? 1. What's 5 to the 0 power? 1. All right, what's 12 to the 0 power? 1. What's 19 to the 0 power? 1. So when you're going for that $1 million and they throw this question out there, what's 15 to the 0 power? They want you to say 0, but you're really going to say what? 1. Or you're going to phone Mr. Parson, and I'll tell you if you include me on about 35% of the pay. Sound good? Sound good? Fine. I'm not answering your question then, Chumzilla.
Okay.
Okay. All right. Anything to the 0 power is going to equal what value? 1. All right. Rock and roll. Here we go. Next, back to this next rule then. The second rule then says this. It says for any non-zero number, a, it says a to, what kind of a power do you have right here now, gang? Negative. It's equal to 1 over a to the n. So as an example right here, quick example right here. If I had something like 4 to the negative 3 power, like I do right down here, that's a bad example. Let's just go maybe 4 to the negative 2 power. This is the same as 1 over 4 to the second power. Okay, that's going to be the same as 1 over 4 to the second power. Okay, let me show you why this is true. All right. Suppose I had 4 to the second divided by 4 to the fourth right here. Okay, are my bases the same here, kiddos?
Yeah.
Exactly the same. So by our rules from the other day, this would be the same as, what's 2 minus 4 going to be? Well, that'd be 4 to the, 2 minus 4 is negative 2, isn't it, gang? Okay, but by rules of repeated multiplication, how many 4s do you really have in the numerator, gang? How many 4s do I really have up here? 2 of them, okay? Do you agree that 4 times 4 is the same as 4 times 4 times really 1? Can I multiply by stuff, or can I multiply my stuff by 1 and keep it the same?
Sure.
I can't. How many 4s are down in the bottom? So by rules of canceling right here, wouldn't a pair of 4s go bye-bye? Wouldn't another pair of 4 go bye-bye?
Yeah.
What are you left with in the numerator here, guys? Numerator. 1 over 4 to what power? Okay, so I say 4 to the negative 2 power, which was generated by rules from the last section, is the same as what? 1 over 4 to the second. Here's a question for you. 7 to the negative 5th power. What is 7 to the negative 5th power equal to in fraction form with a positive exponent? 7 to the negative 5. Say it again for me, Brandon. 1 over 7 to the 5th. Awesome. Okay. So let's jump into some examples here quickly and see if we can't figure out what the heck is going on with these 0 exponents and negative exponents. A lot of your rules, a lot of the problems that they say simplify are going to involve the following. They're going to say, you know what, rewrite the following expressions with what type of exponents? What's it say up there in yellow? Positive exponents. So the first one that I have is 4 to the negative 3 power. We kind of talked about this. How am I going to rewrite this with positive exponents?
1 over 4 to the 6th power.
1 over 4 to the 3rd power. Awesome. You guys feel okay about that? Now, letter B is tricky because instead of having one variable, how many variables exist there? 2. All right. What kind of exponent does m possess? Negative. Well, how about the n? It's just 1. Do you guys agree n to the 0 is really a 1 right here, isn't it? N to the 0 is really a 1. So what I'm going to do is this. I'm going to say that this is really equal to m to the negative 5 times 1, isn't it? Okay, but anything times 1 is itself, right? Yes. So isn't this really equal to m to the negative 5 to this point right here? All agree I can simplify in that form? Now keep in mind, my job is to rewrite this with what kind of an exponent? Positive. I want a positive exponent here. So how am I going to write to the part where I'm at m to the negative 5 with a positive exponent? What's that going to look like in the end? 1 over m to the 5th. Good, Chelsea. Very good. All right. So do you understand why the n dropped out of this? It was just what value? It was to the 0 power, so it became a 1. All right. Have I written everything with positive powers up there? Yes. All right. Okay. Right with positive powers, not with Austin powers. Okay, that was bad. Never mind. Let's roll. Okay. I like this next problem, letter C. Okay. I'm going to start throwing some stuff up here like 13xy to the negative 8. And I'm really going to start talking about a kind of a rule that's a pretty simple rule that involves negative exponents. All right. Here's the deal. We've talked about solving equations a lot here before, right? We said that if I have one value on the left side here that's a positive, if I would move that positive to the opposite side of an equation, what did it become? If I move the positive to the opposite side, a positive became a what on this side? Negative. Negative, right? Moving to the opposite side, okay? Rule I'm going to start throwing out here is the following, all right? In practice C, or an example C, nice star here. Here's what we're going to start doing. When you have problems that are more complicated, it involves coefficients and multiple variables. Here's what I want you to start doing. Okay? Some of the problems you're going to start seeing on the next page are going to have a fraction bar. I want you to start fraction barring this out. All right? Just put a line under that stuff. If there's no fraction bar there, put one there. All right? Here's the deal. Our problem problem is y to the negative 8. Okay? Our problem is y to the negative 8. I want that to be positive, right? Now y to the negative 8th can be rewritten as 1 over what, gang?
Y to the 8th.
You guys agree with that part right there? Yes? All right. So here's the deal. I'm going to split this right here. If that part is 1 over y to the 8th, doesn't this problem really become 13x times 1 over y to the 8th? You guys agree there? Would you agree? Yeah. And isn't 13x really 13x just over 1? Because if you divide by 1, you're really keeping it the same, aren't you?
Yes.
Okay. Now, I'm making this more difficult than it has to be right now, but I'll come to the shortcut here in a second.
Okay, it's been seconds.
Always got to be one of those in the group, right, Mrs. Miller?
Yeah.
All right, what's 13x times 1 up top, gang? Well, it's just 13x, right? And the bottom, what's 1 times y to the 8th, guys? Or gals?
Y to the 8th.
Just be y to the 8th, wouldn't it?
Yes.
Okay, so my simplified form, is everything written up here with a positive exponent?
13.
Yes.
Yeah, we're good, right? Okay. Now here's what I want to get at about shortcuts. Kind of clean some of this up over here. I said put a fraction bar right under that, right? Right? And you know your final solution is just going to be 13x over y to the 8th. Guys, if you can think of it this way, just like in equations, if I had a plus 4 on the left side, it would become a negative 4 on the left side if I put it over there. So the sign kind of switches, right? Well, the same thing's true about bases and their exponents. If I have a y to the negative 8 up top, if I take this negative exponent to the opposite side, its sign is going to do what? Well, what did it do here? Didn't it switch? So can I just say, well, this is negative, so just take this out of here. Take this out of here and move it where? I'll move it to the other side of the line. And if you move it to the other side of the line, sign switches here. Okay?
Yes.
Just simply 13x over y to the 8th. Okay, so I want to check something here quick, notes-wise. You guys okay with that example?
Yes.
Here, I'll tell you what I'll have you do. On your own, go ahead and give those 4 a shot, see what you come up with. Again, on your own, your job is to rewrite these all using positive exponents, or if you can simplify to a whole value, do that. Okay, so take a second and do these 4 problems. 1, 2, 3, 4, go. Shoot questions.
Yeah.
For me?
Yeah.
Like that.
I don't know how to do my math.
Can you give me about 10 more minutes here?
Alright.
Sound good?
Yep. I'm
Mark,
already
you got
charged.
questions?
Yeah. So this is already
We'll be able to use that. That's my all-time favorite. That one there's my all-time favorite. The what? All right, let's roll. Who's got the first one? 33,333 to the 0 power has got to be what value, Brandon? 1. Just 1, isn't it? Because, so what power? 0. We all okay there? Okay, second one, rewrite this with a positive exponent. Well, let's see. How'd you do that one? You got it? Okay, what's up top though still? A 1, right?
Yeah.
So 1 over 7 to the 3rd. We all agree there?
Yeah.
This is a tricky one. You're going to leave the 2 alone right here, but where's that z to the negative 2 going to fly to?
New Orleans, Louisiana.
New Orleans, Louisiana. So it's going south, right?
Yes.
Yeah. Very relevant. Good job. I like the cross-curricular stuff today. You guys agree that I'm going to take the z to the negative 2 and make this a positive exponent by putting it in the bottom?
Yeah.
Where's the 2 going to stay, though?
Top.
So this is going to be the same as 2 over what? z to the second. What am I moving in this one right here? What's going to stay up top? I guess that's a better question. What's staying? 3y is staying, right? What's what you going to have in the bottom now? What you going to have in the bottom?
X to the fourth power.
X to the fourth power, right? I'm going to move that x to the negative 4 to the bottom, so it's a positive value there. Does that make sense to everybody?
Yeah.
Okay, here's a challenge problem for us. What if I had something like x to the negative 2, y to the 6th, over a to the 4th, b to the negative 3rd? Okay? First of all, there's 4 variables up there, or 4 different bases. How many of those bases possess a negative exponent? How many possess a negative exponent up there? 2 of them. Okay? Which variables are going to move to the other side? Is a to the 4th going to move, guys?
No.
It's already a positive exponent, right? We only want to move the stuff with what kind of an exponent?
Negative, so the
Negative.
Negative.
So where's this bad boy going? Where's this bad boy got to go if it's already in the bottom? Doesn't have to go up top? So to rewrite this all positive exponents, up top we'd have b to the 3rd times what's still positive up top here? Well, you'd have a y to the 6th, don't you? And then at the bottom, you're going to have a to the 4th times x to the 2nd. Okay, so you might want to take a second and write that one down, kind of a challenge problem like that. But really the rule is this: if you have a negative exponent, it's positive on the other side. If you have a negative exponent, it's positive on the other side. How do you guys feel about that?
Good.
I gotta tell you what, if you can understand this, I know that there are kids that are juniors and seniors that are taking college prep math or integrated 3 or something like that, and they struggle with this concept. So if you're on board with it, you're doing an awesome job. Okay? Really, if an exponent's negative, what are you doing with it? Moving it to the opposite side of the fraction mark. Okay? This concept is always tough for kids, it seems like. Alright, so if you can remember the rule that says negative exponents, take its base and move it to the other side, the exponent's positive on the other side, right? Okay.
Where is this stuff like proven at? I mean, like.
Well, it's kind of, Mr. Slater, we kind of looked at in these examples like this here, where if I had 4 to the 2nd over 4 to the 4th here, and these were rules from the last section that says I can write this as 4 to the 2 minus 4 power right here, like this, which would be 4 to the negative 2 now, because 2 minus 4 is that negative 2 there. And then we kind of write it out as a repeated multiplication, so the top is 4 over 4 and all this mess right here. So if this is equivalent to this, this is also equivalent to this by repeated multiplication.
I was saying like b to the negative exponent. Where later in math is this used? Like in engineering or anything else?
There's a lot of engineering concepts that go with this. When they start talking about negative exponents, most of the part that you're going to see is when they talk about like half-lives or decay of something. You might have something with a negative exponent because they'll start out like in some of the science classes with something and they'll say it decays exponentially at a rate of like 4%, so your exponent would be a negative 0.04 t, and that's where that stuff would come into play there. So honestly, if something like this here, you're going to see it, I guarantee, on some kind of a standardized test here, but this would really be a big time science application. A lot in chemistry and some physics, but mostly in chemistry is where you see this type of stuff, which you guys will probably take someday, right?
No.
Who said no? Macy Mac. All right.
What?
Chemistry. Chemistry was my favorite science class when I was in school. I was a chemistry and physics guy. I loved it. Okay, I'm going to go back to the first page. Do you guys have everything written down right here? You guys have it all written down here?
Did negative 2 come up?
Yeah.
Okay, let's rock and roll. I guess, Mr. Slater, another explanation would be like this here, too. if we had something like 1/16 times maybe, I don't know, 64 right here, sometimes they start saying write this as a common power. So I look at 16 and 64 and I know that 16 and 64 are bases of 4. So I might write this as 1 over 4 to the second times 4. 64 is 4 to the third right here like that. Okay, and if I multiply this together, this will become 4 to the third over 4 to the second. Your answer here would just simply be 4. 3 minus 2 part there, which really is true because if you take the 64 times 1 up there, 64 over 16 is still that value of 4 also. So they might be looking for common bases and something like that be applicable there. So, but we're not going to get into that much stuff like that. Just kind of the nuts and bolts part here today. Okay.
He's going to show us here in a second, so probably just wait.
Example 2 says rewrite the expression without using a what?
Fraction bar.
Fraction bar. So as an example, I'm going to give you a fraction. I don't want it to be a fraction. I don't want any fraction, which means if you have anything in the bottom, you need to move it where? To the top. Everything needs to go to the top. So if it says rewrite this without a fraction bar, nothing in the bottom. So here's an example. I'm going to say we've got something like 1 over 4 to the second, just to begin with. Okay? Simple one. 1 over 4 to the second. Now, is that written in fraction form?
Yes,
Yeah.
we'll just do it.
Okay.
We have to.
Example 2 says, I don't want this to be a fraction form. So I need to take everything that's in the bottom here, everything that's in the bottom, and move it where?
To the top.
To the
Can
top.
we please move it? Can we please have it in fraction form?
Can you please have a what?
Can we please have it in fraction form?
Oh no.
But why?
John, if everything was easy, nothing would ever be fun.
Okay.
Right?
Yeah.
Okay. So let's have some fun and make it difficult.
Okay, it's your funeral.
Hopefully I'm late for it, okay? Alright.
I'm just trying to entertain everyone.
That's okay. You're doing a great job, son. I gotta be honest with you. That was a good one.
Okay,
That was a good
stop.
one. I don't know if I really had a comeback for that, so. I'll take Abe Lincoln's side in this and say it's better to remain silent and thought a fool rather than speak up and remove all doubt, right? Okay? Hey, here we go on this. I don't want this 4 to the second power in the bottom. That's what it means to not write this as a fraction. So guys, if my exponent is already positive here in the denominator and we say we don't want anything down here, we're going to move it to the other side. What's going to happen to the sign of my exponent right here if I move that up top? It's going to turn to a negative, right?
Yes,
So up top, we still have a 1 up there, but what are we going to join the 1 with now when I move this part in the bottom to the top? 4 to the...
Second.
Negative 7.
Why negative second?
Because you have to switch it.
We're switching it. We're switching sides, so it's moving to the top. You guys agree with that? This positive exponent in the bottom would be what kind of an exponent on the opposite side or up top? It would be negative, right?
Yes.
Okay. So this is the same as 1 times 4 to the negative 2, which simply just becomes 4 to the negative 2 power. We're kind of working backwards from the stuff that we've looked at already. Kind of working backwards from the stuff that we've looked at already. That's what's going on here. Okay, so let's try one that's got a lot more junk in it. Let's go 4x squared over x to the, that's a bad example. Let's go y to the third, z to the fifth. Okay? Is the stuff in the top good?
Yes.
Do I change the stuff in the top? If I want to rewrite this without a fraction bar in it, then what do we have to move? What part has to move, top or bottom? We have to move the bottom, don't we? Okay. So the y to the positive 3 on the bottom would be y to the what up top?
Negative.
And the z to the fifth in the bottom would be z to the
Negative.
negative 5 up top. So what are we going to end up with? Here we go. It becomes 4x squared up top stays the same, right? What's going to come after the x squared now? Yes.
Times y to the negative third.
Yep.
Z to the negative fifth.
You got it. Have I eliminated the fraction bar, guys?
Yes.
Okay, so eliminating the fraction bar is going to help us rewrite stuff. We've got to use this idea of using negative exponents. Okay, there it is. Okay, you guys ready to try a couple?
Yes.
All right. I'm going to have you just do two here quickly. Rewrite the expression without a fraction bar. So here's one. Oops. Yeah. I'll give you 4.
And which one?
All right, go ahead and go there. Guys, did I attach a quick quiz to your notes?
Yeah.
Okay. Okay, again, your job, rewrite all those without a fraction bar. I think we should be pretty close. So, someone I haven't heard from yet this morning, tell me the first one. Mrs. Miller, I'll start with you.
Oh, okay. I got 18 to the negative 2.
How many agree?
I agree.
Okay. All right, Kyle, you've got the next one?
Yeah. And it's 10 to negative 2.
Very good. Okay, third one, maybe a little bit more difficult. Anna, have you got the third one? Times what value up top? So you've got 3c to the negative second. Okay, and then the last one. How about my last one? Max, have you got that last one? Brandon?
X fifth.
Okay.
X to the 5th times.
Y to the negative 7.
Very good, guys. Very good. Okay. So, really, two things that we've looked at today. Writing stuff with positive powers. That's been a focal point. Second focal point is how do I take something that's fraction form and rewrite it without fractions, or without a fraction bar, if you will. Okay? Are we comfortable with these up here? All right. Last example here quickly then, and then I'll let you get going here on some stuff. Guys, in example 3 it says using powers properties with negative exponents. And down below here it says we want to find the product of the quotient. And it says to write our answer using only what? Positive exponents. Now I don't want you to lose sight of what we did last section. Rules of multiplication, rules of division. Okay? First example that I'm looking at here, gang, is to say take these bases right here and multiply them together. Okay? Guys, first of all, what is my base in this? 6. Am I multiplying or dividing? Multiplying. So will I add or subtract? I'm going to add. So would you guys buy that this is really 6 to the 12 plus, what type of 4?
Negative.
Negative 4 here, right? Okay, as we are multiplying, like bases, you would have to add the exponents. However, one of the exponents this time is what kind of exponent? Negative, right? Rules still apply. You're going to go 12 plus negative 4, which is really the same as 12 minus 4, isn't it? So what's this going to be, gang? What is that 12 plus negative 4 going to be? Max again? 6 to the 8th. Very good. All right, next one. Next one. Keep in mind, what kind of exponents? I should back up and ask myself the question, is my exponent okay under this condition?
Yeah.
positive. Let's rock and roll the next one. This really says 7n to the negative 4 divided by n, and this is really n to what power, gang?
1.
1. Okay, watch this. 7's going to stay a 7, isn't it, by our rules from the last section? But now I need to take negative 4 and subtract what value here?
1.
Okay, so if I'm at negative 4 and subtract 1 more, where does that move you to?
3.
Other direction.
4 negative.
So what kind of 5, kiddos?
Positive.
Negative, right?
Negative.
If I take negative 4, if it's 4 below 0 outside and it goes down 1 more degree, where are you?
5.
Negative 5. So would you guys agree that this is 7n to the negative 5 by the rules that we used in the last section?
Yeah.
So I'm all done with this problem, right?
No, we need positive.
We need positive exponents, right? So we're going to keep the 7 up top, so we'll put a fraction bar here. Where are you going to move that n to the negative 5 now?
Below.
So what's this going to look like in the form that they're asking us to put this in?
7
7 over
and positive 5.
n to the 5th. Excellent work. That's it. That is it.
Okay.
So, Mr. Parsons,
Yeah.
you really need to make sure they're reading what
You've got to
it
read the
wants for
directions
the
carefully.
answer.
What is this asking me to do? Am I writing it without a fraction bar, or am I writing with all positive exponents? You've got to make sure you pay attention to that, okay? So thanks for reminding me there, Mrs. Miller. Okay, questions about this, number 1? Anything you guys want to add at all? All right.
Wait, there's something I want to add.
Yeah, John, what are you going to add?
Can we have ice cream sometime?
Ice cream.